Okay, so PD4. All right, so we've got this function given, we've got a point given, and we want to compute the partial derivative by interpreting it as a directional derivative. In other words, we want to compute the directional derivative of this function f at the point 3 comma 4, but importantly, we want to interpret it as a directional derivative. We've got to figure out what is the vector, what's the velocity vector here. Well, we're doing a partial derivative with respect to x. That means that the velocity vector is e1. Right, does that make sense? Yeah. Okay, so E1. So the problem says let's compute this directly. Okay. Okay, so what we have is this is derivative with respect to t at the point when t is equal to 0 of f of, well, 3, 4 plus t times my velocity vector is 1, 0. So that's going to be derivative with respect to t when t is equal to 0 of f of 3 plus t, comma 4, and that I can compute. I can plug this x and this y into the function, and let's see our form. What's right? It's x squared y cubed minus y to the 23rd. Okay, fine. X squared y cubed minus y to the 23rd. Okay, so I've just plugged in, this is x, and that's y. Plugged those into the formula for f, and I got this, right? Okay, so let's take the derivative with respect to t. Now, well, let's expand this a little bit so the t derivative is a little bit easier. This is 9 plus 6t plus t squared, t squared. This is all times 4 cubed. Let's see, what is 4 cubed, by the way? That's 64. Why don't I just write that as 64? And then minus 4 to the 23rd. Let's not compute that. Exactly. Okay, so t derivative of this thing, no problem. It's 6 plus 2t, all times 64. And conveniently, this is all constants here, so its derivative is 0. Lovely. Let's plug in t equals 0, and we get, okay, that's 0. So 6 times 64, which is 384. Cool. So that's the first part, and then the second part is just to do it the much easier way, just to say, well, let's, partial with respect to x of x squared y cubed plus y to the 23rd is 2x y cubed, which at the point 3 comma 4 is 2 times 3 times 4 cubed, which is 384. So this is another one of those things where it's like, well, we did it that way, and then we did it this way. Which do you like better? I like this one better. This is the moral of this story is, don't we love partial derivatives because they're so easy to compute compared with the sort of the brute force direct alternative. Yeah. Yep. Everybody happy with this one? Okay. Stop the recording.